look at this problem. So we talked about mean value theorem and Rolle's theorem. And mean value theorem is like the more generic one of the two. So they both require that your function be continuous on the closed interval, differentiable on the open interval. And mean value theorem says if those two things are true, somewhere the derivative equals the slope between the endpoints. Rolle's theorem is a special case where the endpoints are the same, so the derivative would equal 0, because the slope between them would be 0. So the question is, suppose that f of 0 equals negative 3. That is not a straight line at all. Okay. If I were to plot a point, f of 0 is negative 3. The derivative is less than or equal to 5 for all values of x. How large can f of 2 possibly be? And I'm going to add in. Assume f of x is a polynomial. Okay, so if I tell you it's a polynomial, what do you know then? It's differentiable, it's continuous. So that means mean value theorem, Rolle's theorem, they would both have to apply here. Now, Rolle's theorem requires that the endpoints be the same. Did I even give you any endpoints? No, so we're really thinking mean value theorem. All I've given you is one point, and I'm asking about f of 2, so when x is 2, what is the largest that can be? Okay, so whatever that point is, just going to make up the value. My x would be 2, and my y value is to be determined. That's what we're trying to find. But the other thing I know is that the derivative, what's the biggest value our derivative ever hits? 5. So would you guys agree that the largest value for 2 would be when the derivative was 5? Okay, my highest value would give me my largest. So think about mean value theorem tells us that somewhere the slope between the endpoints equals the derivative. So we would need to find the slope between our endpoints. Okay? I'm just going to say by MVT, mean value theorem. So if we did our slope between the endpoints, y minus negative, so plus 3 over x minus 2. And we've agreed that the biggest y value would happen when our slope was 5. Hold on, I flipped something, didn't I? Shouldn't this be 2 minus 0 on the bottom? Because I did my y value first. So that would be a positive 2. So y plus 3 equals 10. So y equals 7. So the largest possible value f of 2 is 7. If it were any bigger than 7, that would make my slope bigger than 5, and we knew on this problem it could not be larger than 5. All right. The next couple theorems on here, I'm really not going to talk about much because they're not necessarily something super important. And we kind of already know it. If the derivative is 0 everywhere in the interval, then it had to be a constant function. Horizontal line, that's the only place where the derivative is always 0. And if two derivatives are equal, then the only difference between them is a constant, which we've kind of seen those things before, so they really don't have much bearing here. I put them on just because they're in your book and I thought I should mention them. But I want to do one last example and then give you guys some time to work on our problems from yesterday. So, mean value theorem problem. We have a function Alright, so to use mean value theorem, it has to be continuous and differentiable. Where is this not continuous? At -2. Is that in my interval? No, so we don't have to worry about that. So our first condition, it is continuous on the closed interval 1. Second thing, to check if it's differentiable, what should we do? Derivative. Okay, we have to do quotient rule. Low T high minus high below over low squared. All we're really worried about is where is this not differentiable? Where does this derivative not exist? What makes the derivative undefined? -2, when the bottom is 0, and that's the same. So since that's not in my interval, it is differentiable on my open interval. Then we would just stop and say we can't use Rolle's theorem because it is not continuous or differentiable here.
So when was that one where 0 was an interval and 0 wasn't?
Because it was an endpoint. It doesn't have to be differentiable at the endpoint. So if I found this wasn't differentiable at -1, as long as it was continuous there, we could keep going. Alright, so then that means we can do mean value theorem. So mean value theorem tells us that somewhere this derivative is equal to the slope between the endpoints. So we need to find our points. If our x is -1, so if you put in a -1, the opposite of -1 squared would be -1 over -3 plus 6. So we get -1, -1/3 for one of the points. The other one, if we plug in a 3, we get -9 over 9 plus 6, so 15, which reduces to our -3/5. How do we find slope between those? Okay. There's 1/15, I think. Let's double check this. You guys are way too trusting. Just assume that I wouldn't lie to you. Okay, so now what do I do? The derivative equal to this. All right. Okay, it's kind of ugly, but let's roll with it. If we cross multiply, if we think about this, how would you square that? FOIL. Can I FOIL and multiply by a negative 1 at the same time? So we would get a negative 9x squared. Let's see, that would be plus 36 and minus 36x minus 36. Okay, quadratics, we want them to be equal to 0. So if I add that over, what could I divide everything by? Let's divide everything by 36 and give us a much nicer problem. So then we would have x squared plus 4x minus 1 equals 0. Is that one we can factor easily? We would try. Is anything multiply negative 1 and add 4? No, so quadratic form. Opposite of b plus or minus the square root b squared minus 4ac all over 2a. 16. Okay, so we have to break down the square root of 20. So that would be 4 and 5. So 2 radical 5. So we get negative 2 plus and minus the square root of 5. Now, what's the final thing I need to check? This was a big problem. If they're in the interval. We're looking between negative 1 and 3. If you do negative 2 minus the square root of 5, you get a negative 4.2. So does that work? No. If you do negative 2 plus the square root of 5, you get a 2.36. So that one works. So the only one in my interval is negative 2 plus the square root of 5. So I wanted to work out one ugly problem with you guys. I'm just kind of show you. We can still do it, just some ugly algebra along the way. You may have to do quadratic formula. Yesterday, I gave you that handout. And you got